Okay, so related rates. Related rates is basically a application of implicit. So if you remember implicit, when you take the derivative, say with respect to x, of something with y in it, like this, the derivative of y with respect to x, you literally get dy over dx. When the variables don't match, we end up with these differentials. Okay? So in related rates, we take the derivative of these equations with respect to time. So when we take the derivative of area with respect to time, we get dA over dt equals pi, which is just a constant. Then we take the derivative of radius squared, which is 2r. But since variables do not match, we also get dr over dt. So this is basically telling us that our change in area over change in time, because remember the derivative is slope. It came from the equation change in y over change in x. So dA literally means the change in area over the change in time is equal to pi times 2r times the change in radius over the change in time, which is what we expect. The rate that the radius is changing directly affects the rate that the area is changing. Okay? So that's basically what we're doing. We're taking the derivative of these with respect to time, and we're getting these differentials. So this is the volume of a cylinder. When we take the derivative of the volume of a cylinder, we get dV over dt equals, since we're doing product here, we have the height times the radius. Pi is just a constant. I'm going to group my pi r squared together. So I'm going to get 2 pi r dr over dt times h. Since I have to do product rule here, that's the derivative of the first. And then the derivative of h is dh over dt. Now, some people would take out your common factor of pi and just leave pi out when you did it and just get pi and then parentheses with everything inside. Either way is acceptable. And then this last one, again, we're taking the derivative with respect to t. So the derivative of a squared with respect to t is 2a dA over dt plus the derivative of b squared, which is 2b dB over dt equals 2c dc over dt. Okay? So that's how related rates work. We take the derivative of both sides with respect to t, and every time we take a variable's derivative, we end up with some kind of change in time. Okay? So let's do a direct application. Okay? So a 13-foot ladder leans against a vertical wall. The bottom of the ladder is sliding away at a rate of 2 feet per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet from the base of the wall? Okay? Well, the best thing to do is to draw a picture. Okay, a lot of these we're going to be drawing pictures for. So we've got this wall. It's a vertical wall, which means this is a 90-degree angle. Okay? We're assuming that it's not some wonky wall. Then we have this ladder that's leaning up against it, like this. Okay? They've told us that this ladder is 13 feet tall. Okay? Again, we're saying that this is a right angle. So this creates this triangle. So let's say this side is A, this side is B, and of course this side is C. Now, the other information that they've given us, they said the bottom of the ladder is sliding away at a rate of 1 foot per second. 2 feet per second, sorry. So that means this point right here is sliding this direction at a rate of 2 feet per second. Okay? So what does that represent? Well, that represents how side A is changing over time. So what they've given us is dA over dt. That is 2 feet per second. And we know it's positive because A is actually getting bigger. So side A is actually getting big over time, so the side is increasing, so that's part is positive. Now, we're looking for how fast this side is sliding down. So what we're looking for is dB over dt. That's what we're looking for. Okay? Now, we got to figure out, okay, well, my situation is basically a right triangle. So what equation do we know of that deals with a right triangle that has sides A, B, and C? Pythagorean theorem. So that's the equation that relates everything that I need. That's also the one we just took the implicit derivative of. So going back up there, we have 2a dA over dt plus 2b dB over dt equals 2c dC over dt. Okay? Now, let's start plugging in what we know. Well, first thing I know is I've got 2's all across the board, so I divide both sides by 2. We can get rid of all those 2's and not have to deal with them. Okay? Do I know what A is? Well, yeah, they told me that we're looking for this specifically when this side is 5 feet. So A is 5. Do I know what dA over dt is? Yep, that's 2. Plus, do I know what B is? Well, they don't tell me what B is, but since I'm dealing with a right triangle, I can do Pythagorean theorem and find that B is actually 12. Now, dB over dt is what we're looking for. Okay? Do I know what C is? Yep, C is 13. Do I know what dC over dt is? Well, they didn't tell us what dC over dt is, but we should know what it is. Well, what does dC over dt stand for? Well, dC is how this side is changing. There's a ladder. Well, is the ladder changing? The length of it? Well, we better hope not, because if it is, then we've got real issues. But since the ladder is not changing, this is actually 0. So when we deal with these kinds of things, when things stay a constant height or a constant length, they're not changing over time. So our differential, dC over dt, is 0. So let's simplify now. Okay, so we got 5 times 2, which is 10, plus 12 dB over dt equals 0. We're solving for dB over dt because that's what we're looking for. So we move the 10 over, we divide by 12, we get dB over dt equals negative 10 over 12, which reduces down to negative 5 over 6. And this is feet per second, which makes sense. Okay, we should have known when we started this that that was going to be negative. And we know it's negative because this right here is going down, which means this side length B is getting smaller or decreasing. So our end result should have been negative. If that had been positive, then we would have had to go back and check to make sure that we hadn't done something wrong. But basically, that's it. The hardest part about these problems is figuring out the information that they gave you and what it represents in my problem. 9 times out of 10, the picture or whatever situation they're giving us tells us what equation we're going to be using. Obviously, we drew the picture and we realized we were dealing with a right triangle. If you start off with a spherical tank or a cylindrical tank, that shape is basically what they're telling you you're going to be using, okay, based on the equations that you need. But that's it. That is related rates, okay? Just make sure that you're writing down the information and reading the entire problem.